Good afternoon, students. We'll start now. So today we will be solving the numerical based on base classifier, but where the attribute is continuous valued. Okay. So here, they have mentioned that solve this using decision tree, but same data set can be used and can be solved using base classifier. Let me search. Okay. So here we have a refund. So we have yes and no values. That means a finite number of values. That is, this attribute is a discrete one. Then in marital status, we have single, married, and divorce. Three values are there. Again, this is a discrete valued attribute. But taxable income. Okay, so here we have, okay, we can have any value here. Okay, it is continuous valued attribute. Okay, so no value is repeated. Okay, and we have a cheat. Okay, no and yes. So consider this as the output attribute. Okay, and these are my xi's. Okay, this is input attribute 1 2 3, and this is my y. Okay, let us solve this by using a base classifier. Okay, and we have to classify. This problem is given for the decision tree. Okay, but consider we want to classify one sample uh, given as X equals to refund equals to no, status equals to married, and income equals to 120. Okay. So I have the same problem here. Okay. Now, in order to calculate the conditional probability for that continuous valued attribute, we have to assume that this attribute follows the normal distribution. Okay, so in previous chapter also we have discussed this normal distribution. Okay, also known as a Gaussian distribution. So it follows this pattern. Okay, so we'll assume that, and we'll be calculating the probability for that attribute using this equation. Okay, so the equation is probability for that attribute given a class equals to 1 by root of 2 pi sigma square. So this is the variance between I and j. So this is the jth attribute, sorry, ith attribute and jth class. Okay, the variance between these two, and e raised to power minus ai minus mu ij. This mu ij is the mean. Okay, mean of this given values, square of that divided by twice sigma square ij. So we are going to calculate, we are going to use this equation for calculating the conditional probability of that continuous valued attribute. Okay, then here we can calculate the mu I by taking a mean. Okay, and we'll be calculating this variance. Okay, so let us solve this problem. So let us call this data set as tax data set. Okay, so this is our numerical number 4. It is asked for 8 marks. Today's date. Okay, based on tax data set. Okay, so whether based on this parameter, whether he will evade the loan or not. Okay, so let us start. So we have two classes here. Okay, the output label is having two classes, no and yes. Okay, so we are interested in finding the given sample x equals to, so the values of given sample is refund equals to no, the marital status equals to married, income equals to 120k. Okay, so refund equals to no, marital status equals to married, and income equals to income equals to 120k. So this is the given sample and we want to classify it in two classes, either no or yes. Okay, so we are interested in to find the probability of yes class given sample x and probability of no given sample x. Okay, and we will classify this sample to that particular class which is having the higher probability, right? Okay, so we'll continue with this. So probability of S given X equals to, so according to Bayes equation, so it becomes probability of X given yes into probability of yes divided by probability of X, right? So the probability of S can be easily find out from this, right? So we have total 10 samples given. So out of 10, how many are yes? 1, 2, 3. So probability of yes class is 3 by 10. Okay. And no need to find out the denominator because it is repeated in both the terms. Okay. And X is made up of these three attributes. Okay. So let us split that. So X is refund equals to no, then marital status equals to married, income equals to 120k given yes into probability of yes divided by probability of x. Okay, now we know according to the assumption of naive Bayes classifier, each attribute is independent and contributes equally, right? So we can divide this, right? So we can divide this probability like this: r equals to no given yes into probability of marital status given yes into probability of income equals to 120k given yes into probability of yes divided by probability of x. Okay, now we know how to find this probability. Okay, so you have to look for the rows where you have this pair, refund equals to no and class label as yes. Okay, no yes की pair देखना है. So yes यहाँ पे है no 1 2 3, right? Okay, so 3 out of 3. Okay, 1 2 and 3, yes, 3 out of 3. Then similarly for this one also. Okay, so marital status equals to married. Okay, so married and yes की pair देखिए 0. Okay, 0 divided by 3. Okay, and as this is 0, no need to calculate this. Okay, anyway the total multiplication is coming out to be a 0, right? So divide by p of x, the probability is 0. Probability of this sample belonging to this yes according to the Bayes rule is 0, and obviously as this is 0, okay, let us see what is the probability we get for no class. Okay, if we don't get 0, okay, obviously it will belong to the no class. Okay, as the S class probability is 0. Okay, so we'll split it. So probability of no given x equals to probability of x given no into probability of no class probability of x. Okay, so x is made up of three attributes. Okay, split that. So first is refund equals to no given class no into probability of marital status equals to married given class no into probability of income equals to 120k given class no into probability of no. Okay, this one probability of x. Okay, now we can calculate this value. ओके हमें नो नो की पेयर फाइंड आउट करना है. ओके रिफंड कॉलम और इवेड कॉलम में नो नो होना चाहिए. सो देर आर 10 minus 3 7 no's 1 2 3 4 5 6 7 7 no's. Okay 1 2 3 4. Okay so this is 4 by 7, right? Then married equals to no. Okay so married no की pair 1 2 3 4 4 by 7 into this we have to calculate I equals to 120k divided by no. Okay till this point everything was similar. Okay as that of a previous problem. Probability of no find out karte out of 10 7 are no, so 7 by 10. Okay this we don't know. Okay how to calculate, as this income column is continuous value. Okay we have to make one assumption that it follows the normal distribution. Okay write that assumption as taxable income attribute is continuous valued. We assume it follows normal distribution. And with this assumption, we can now apply this Gaussian equation on that. Okay. So the probability of that attribute, let's define that as xi. In our case, it is our income column given class Cj equals to 1 by root over 2 pi, then the variance between ij into e to the power minus ai minus xi mu ij square 2 sigma square ij. Okay where the sigma square is given by, okay we know the formula of variance, right? So we subtract the value of each sample from the mean, right? Mean, and we take a square of that and divide by, so we do the summation, and as we are considering only the samples, we have to divide by n minus 1. If you consider the entire population, you have to divide by n. Okay remember that difference. So we are talking about few samples, so we divide by n minus 1. Okay this is how we will calculate the variance. So remember these formulas. So we have this for the probability, and where the sigma square ij equals to summation the each value minus the mean value divided by, as we are talking about the samples, divided by n minus 1. Okay so let us calculate this value. Okay so first we'll find out mu ij. Okay so the samples are, now we are talking about class equals to no. Okay cj is what? Okay cj is no class. Okay so just refer the rows where class equals to no. Okay so we have no in 7 rows we have no, so we have to take the mean of those 7 values. Okay, so 125 plus 100 plus 70 plus 120 plus 60 plus 220 plus 75. Okay, total 7 samples are there. You divide by 7. Okay, this is a mean. Okay, now I'm representing that you have to refer the ith column. J means you have to refer to the jth rows. Okay, so the result of this is 110. Okay, so this is 110 mu ij. Similarly, let us calculate sigma square because it is required here. Okay, so sigma square ij. Okay, now, so what we have to do, every value minus mean divided by n minus 1. Okay, and square of that. Okay, so we have the values here. So 125 minus 110 square of that plus 100 minus 110 square of that, 70 minus 110 square, plus you do it for the remaining values. Okay, last one I will write 75 minus 110 square of that divided by 7 minus 1. Okay, just I'm putting the values here. Okay, refer those columns and rows. Okay, don't consider all the rows. The value that you will get is 22,975. 2975. Put these values in this equation. Okay, so probability of refund equals to 120k given class no is equals to 1 by 2 pi into, you have the variance score which is 2975. 275 e raised to power minus, okay, xi, the value of given sample, that is 120. Okay, the sample value is 120 minus 120 minus then mu ij, that is 110. Okay, mean value square of that divided by twice this value. Okay, 2 into 275. Okay, and the final result that you will get is 0.0072. Put this value in our equation number 1. Okay, put this value here. Okay, obviously it will be greater than 0 because the probability for yes class, okay, it is 0. It is greater than 0. You can classify this sample as no. Okay, so putting the value in equation number 1, the probability of no class given x, okay, some value will be there which is greater than 0. Okay, you can write as probability of no, class no is greater than probability of yes. We can classify given sample as yes. Okay, so any doubt how to calculate these values? Just remember these equations. Okay, they can directly give you the equation that you have to use. Okay, if they want to use different distribution, they will give its equation. Okay, but if it is not given, okay, assume that it follows the normal distribution, and this is the equation that you have to use, where mu ij is the mean. Okay, and we have to calculate, you have to consider particular column and rows and calculate the mean. Similarly, we can do it for yes class also, but what happened, we got this zero value, that's why we skipped this probability. ये probability हमने निकाली ही नहीं. Okay, one thing we can notice from the data, if you look closely, if I try to plot these values, okay, so the list value that I have here is, let me zoom. See here, the list value that I have here is 60. So I have plotted here, and the corresponding class label is no. So no. Then we have 70 value. The corresponding class label is no. Then 75, no. Then 85, yes, then 90, yes, then 95, yes, and 100 is no, 120 is no, 125 is also no, and then we have 220, no. Okay, so if you observe here, we have no, no, and in between we have yes, and then again we have no. And the value which is given here is 120, which is falling after this threshold. Okay, so it was expected that the probability for no class for this sample will be higher. Okay, so if you calculate this probability, it is, so I expect you will get the value which is lower than this value. Okay, ये है 120 की probability for no class. Okay, from our observation, okay, we should get the probability, less probability for yes class. Okay, so this is how you have to understand the data. Okay, you plot it, you will get better understanding about this data, and then you can guess the answers. Okay, any doubt? Anyone? Shall I repeat this numerical? Tanushri? Tanushri,
Yes, sir.
have you understood this numerical?
Yes, sir.
Okay, Runal?
Yes, sir.
Okay, so take a screenshot of this numerical. This is the problem. Okay, so nothing is mentioned about this attribute. Okay, so that we have to infer from the given data, whether we are having a discrete valued attribute or continuous valued attribute, that we have to infer. Then we have to decide about the equations that we have to use. Okay, this is the problem and this is the solution. Let me zoom out. I hope this is visible. The second page. It is not visible. Okay. Now, from these examples, we'll try to find out one problem with base classifier. Okay. Now, what happened here? So there were no samples of this combination, right? Married and yes. Okay. The actual problem is we have very limited samples. Okay, and we don't have one entry for married and yes combination. Okay, and because of that only the entire resultant probability became zero. Okay, because we have a multiplication, so the entire probability becomes zero. Okay, what if consider we have three attributes. uh, So probability of x1 given one class, let's say yes, into probability of x2 given yes, into probability of x3 given yes, and then probability of yes will be there divided by probability of x, right? So we have three attributes, x1, x2, x3, and this one. Okay, we are interested in finding the probability of yes given x. Okay, this is according to our base equation. Now let's say the probability of this is 1 into probability of this one is 1. Okay, but there is no sample of this and the probability becomes 0, and this is more likely class. So let's say the probability of this is, so we have 10 samples and we have 8 samples of that. Okay, so ideally the probability of this class should be higher, but because of only this attribute, okay, we don't have that sample, we have 0. Okay, and resultant probability is 0. Okay, so the main reason is we have very limited samples. Okay, and because of this multiplication, okay, we are getting 0. Now, how to overcome this problem? Have you understood the drawback of base classifier? If you don't have the sample, the count will be 0. Okay, and the entire probability of that class will become 0. Okay, now in order to avoid that problem, what we do, we add dummy samples for each category. Okay, so married yes was not there, right? So we'll add one sample of married yes. Okay, we'll add samples for each possible combination. Okay, so that there will be no 0. Okay, and we'll get some number. That is the simplest solution for this problem. Okay, so we'll see that through one example. Okay, let us discuss one more problem and then we'll stop. This is again asked for 6 marks, sorry, 8 marks. Okay, and we have two sub problems here. Okay, so each one will be for 4 marks. So consider the given data set x1 to x6. Okay, so these are the input attributes, class is the output attribute. We have 0 and 1s. Okay, so we have discrete values. In the class label we have yes and no. Okay, the probability of yes class is 1 by 2. Okay, because out of 6 samples 3 are having yes value. Okay, the probability of no class is 1 by 2. Okay, and we have to predict for this values. Okay, so this is the x1 value, this is x2 value, x3, x4, x5, and x6. This sample is given, you have to predict the label. Okay, whether it is yes or no. Okay, so it is very easy problem. So let us see the steps for one problem. So what we are interested in, so let us call this sample as A and this sample as B. So we are interested in finding the probability of yes class given sample A, which is this one, right? According to base rule, it will become probability of A given yes into probability of yes divided by probability of A. Now A is made up of 6 attributes, x1 to x6. Split it, so we'll get, so first probability of A given as yes equals to probability of x1 equals to 1, right? Probability of x2 equals to 1, probability of x3 equals to 0, probability of x4 equals to 0, and so on. Okay, and calculate these probabilities. We know that there are 3 samples containing yes, right? Okay, वो तीन में से x1 equals to 1 कितनों में है? So okay, refer only first 3 rows. Okay, in those 3 samples we have 1 in 2 rows. Okay, 1 1, so its probability will become 2 by 3. Okay, then into x2 में कितने 1 है? 2 samples में. Okay, 2 by 3. x3 equals to 0. Okay, यहाँ पे 3 में से तीनों में भी zeros है, so 3 by 1 into, okay, यहाँ पे 1 by 3. x4 equals to 0, y rows में कितने zeros है? So 0, 1 है, so 1 by 3 and so on. So we'll calculate the probability of this probability into probability of y is 6 sample में 3 yes sample से 1 by 2. Okay, this is the result for this. Okay, similarly you calculate for no class. Okay, and then you classify. Okay, so this is how you can proceed with this problem. I hope you understood this problem. Please take a screenshot and try to solve and share the result in your group. Okay, and you can cross check the result. Okay, so we have solved total 5 numericals based on base classifier. In tomorrow's lecture, we'll be discussing how to overcome that drawback. Uh, Tomorrow we have a lab, right? So we'll be implementing the base classifier. In Friday's lecture, in Thursday's lecture, we'll be seeing the solution for that drawback, and that will complete our unit number 3. Okay, so please mark your attendance. So we'll stop here. You can leave.